The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Welcome back to the Electronics Inside, the show where we tear down toys, tools and appliances just to find out what's inside. I'm David, and in this video we're going to be tearing down a DSLR camera. SLR stands for single lens reflex, and what that means is there's only one hole on the front of the camera. It's not like when we looked at the instant cameras and there was always a second lens for the viewfinder. So whatever input you make to the main lens is what you see through the viewfinder. Now historically this was important for photographers because when shooting on film you didn't have a screen where you could see what the sensor was seeing. So you wanted to know exactly how sharp, how zoomed, how cropped. Someone with a good eye could probably tell you how exposed the photo was as well. With digital cameras, it's a little less necessary. I think that's probably slightly controversial because you get a real-time preview on the screen. But the SLR cameras tend to be synonymous with physical size and quality as well, and in the digital age they've definitely kept up that mantle. If you want a good quality camera you would have still gone for a DSLR, a digital single lens refract. So to make this work you've got all this lens assembly on the front, and there is a mirror here in front of the sensor at the back, and the light goes up here and I understand it actually bounces around a prism before coming back out through the viewfinder. Now that principle hasn't changed, and when you look for light through here from the viewfinder you press the shutter and the mirror moves out of the way, exposing either the film or the sensor, and that's how you record your image. I'm probably going to regret this because I have a feeling this is going to be way more complicated than even I'm expecting, and I'm expecting it to be complicated. So I think we just need to start it and see how it goes. I'm probably going to fail to even work out how to get into it. One way to find out. As with all of these, this was bought off eBay broken, so I didn't pay much for it at all. Didn't come with a battery, it comes with a CF card for storage, which is not as uncommon as you might think even in today's age of SD cards. So the optics on SLR cameras are obviously replaceable and you can change that. If I show you my close-up camera that I use, this is a variable 18 to 55mm lens, and again even on this I can take the lens off and replace it for a different one. The two that I shoot with overhead and up front actually have fixed lenses because I don't touch them. I press go and leave them. And of course on top you almost always have some sort of custom mounting for a flash or accessory normally. And it has a built-in flash as well, which has probably never been used. If you're using a DSLR camera, I would think it's probably quite rare that you use the built-in flash. I would say you either compensated with the settings of the photo or you had a decent external flash. I'm making big judgments here that I have no experience to back up, sorry. So on the inside of this is an 35 to 70mm variable zoom lens. It's also got an autofocus. Now I'm pretty sure, I will try my best to get this apart, I have no idea how that's going to go. I'm pretty sure that the contacts on the back of here tie up with these to actuate a servo to manage the focus. And the zoom is always manual. If I open that up, you can see that adjusts the aperture, and that just changes how much light is allowed through the camera to the sensor at any one time. I should say, I'm throwing all these photography terms out there. I feel a lot with this, a lot like I did with the Cambridge audio teardown. You know, I'm slightly competent in the area. I could probably throw some technical terminology out there, but it's really not a field I'm an expert in. I've had to learn some basics to do this, heavily supported by the production team. Hi Max. Yeah, I would never think I could teach somebody photography or call myself a photographer. That'd just end up horribly with nothing good coming out of it. But you know, I know enough that I can take one of these apart, he says, failing to take it apart. Clearly would have been the right screwdriver to have started with, never mind. Okay, that's the battery flap that's come off the bottom to the accessory port, and already seeing some nice circuitry. Actually, there's more on here in plugs and connectors than I'd expected already. Oh wow, that's actually the contact for a switch. So super steady shot, which would be the anti-vibration feature on this lens, actually just slides up and makes contact between those two pads on the back of the circuit board. And obviously they had some issues with the spring contacting something, so you've got a little bit of insulation tape there. Interesting. Oh, ooh, wow, connector on the bottom of there. I hadn't expected this board to have actually some proper processing on board. Haha. Caution, for continued protection against fire, replace only with the same type of rating of fuse. So somewhere, this thing's hiding fuses. I feel like down there they felt they were being useful putting this on the world's shortest ribbon connector. It actually just looks like it's the start of a flex PCB in the screen assembly, which is... it's only clipped together. Okay, there's another sticker about fuses and ratings and continued protection, and all of a sudden this corner up here, which was under the screen, is a sticker which matches these three plugs up here and these inductors. A weird place for a label. I was just about to say the massive number of connectors and ribbons and multi-layers and stacked PCBs reminds me of the video camera we did, and then I realised that was Sony too. Do Sony have an MO? Missed one. Which hides another one. Oh, layers of connectors. Okay, this still isn't lifting out, so what is holding it in? There's some chunking massive connector on the bottom, probably. Let's see what else we can tear apart. I have to admit, I'm interested to what people's first digital cameras were. Did people take the plunge early and go with DSLR bridge cameras? I think bridge was a single piece camera that sort of mimics some of the functionality of an SLR, which was only really an option once they went digital. You couldn't do that with a film camera, as far as I know. But what about the kind of mini digital cameras? I mean, I know everybody these days just sort of goes straight to mobile phone photography for their first camera, probably. But those that bought a digital camera, what did you buy first? Let us know in the comments or over the Element 14 community. Okay, I wasn't expecting to be coming in the front quite like this so soon, but can't work out where else to go, so that's what we're doing. I'm pretty sure this switch down here purely tells the camera whether the lens is actually locked in position properly. So it probably won't lift up the shutter release, which you can still see in there, hopefully, until there's a lens in place, just to keep the sensor clean, make sure it's free from defects. Yeah, as you press that button, it pulls the actuator arm there, so it releases the lens. So the lens release button and spring, the front of the case. And now we can see a very nice big capacitor, which will be for flash, which means this bit round here, it's been weeks at least since this had a battery in it, but I am still going to take this out and put it to one side as quickly as I can, because I don't like electrocution. There we go. Have a look at some of the buttons and the flash on here. The function select buttons are pretty common to big, decent cameras, but I've got to say there's some sort of consistency with the quality of the actual encoder wheel and little push button in the middle of this one. I've never held or used a digital camera and gone, ooh, that feels cheap. Oh, that's cool. So this is not actually just a jog wheel. You can get sort of rotary encoders that don't give you ultimate position. They only give you relative. So when you turn them on and you think you turn it this way, there's just two contacts that go 1, 2, 1, 2. Or if you turn it the other way, they go 2, 1, 2, 1. So it knows how many in which direction it's turned. But because this needs to know ultimately where it is, it's actually got these 1, 2, 3, 4 little contacts. And you see they go onto this tiny little flex PCB, which, depending on how many are paired up or grounded or what, give it its ultimate position. So this is a full-blown rotary encoder. That's cool, but that's a component that will definitely wear out. And again, nice rotary encoder this side as well for the camera mode. Although this one's actually continually rotatable, whereas the other one actually had a limit on it. And the shape of these traces is not an accident. When you're designing a rotary encoder, it's actually important to, I think it's grey space you have to be aware of. And basically, if you just sort of did binary counting and you went 1, 2, 1, 2, you increase your chances of the circuit missing a point where it may have jumped to or something. So you have to be careful, and actually you end up laying it out so similar contacts are not next to each other. So that flash looks like it's soldered in place. All right, if you're of a delicate disposition, please look away now. I didn't enjoy that either. And those 4 pins are actually soldered through the previously flat flex connector. And I find it weird because this ribbon that goes all the way across here is actually joined to a separate assembly. I can't see how, whether that's soldered. Of course it is. There you go. And there are 2 rotary encoders. Okay, having now had that conversation about the jog wheel styles, this one's a relative change rather than an ultimate position. So I wonder if this will help make my point. Yeah, there you go. So you see, this wheel has actually just got 2 pins that connect, and on its trace, you can just see that the 1 and 2 position are slightly staggered. And depending on which one makes and breaks first or second, you can work out whether it's being turned clockwise or anti-clockwise. Whereas these ones, you would know at any given point which position that's in. That's surprising. I kind of thought that these 2 leads would have gone to internal and external flashes, but no, the leads all appear to come up to this flash. Again, here's the cap for the flash. I want to be very careful around that. Surprising amount of integrated circuitry associated with charging and monitoring this capacitor. And that'll be the input pretty much straight off the battery. Nice big inductor. And then we've got this, which was on a separate ribbon cable, although it's physically close to it. I have to look up what that is, see if it's got a particular purpose that meant it had to be close to the flash, but I can't really place what that might be, unless it's thermal protection, because that would have been wrapped pretty much around that inductor. So many components. I'd love to see an assembly manual for one of these, because, well, I suppose it's not going to be one person that needs to know. Well, I suppose the repair manual for one of these must be ridiculous. You know, just an exploded view photo of how the assemblies all fit together would just kind of blow my mind, I think. Down the side here, you can see the gear reduction train for the aperture ring. So this top half actually interlocks with this ring for adjusting the aperture on the lens. I thought there'd be much more direct drive than it is. Going through all those gears introduces so much backlash and makes it harder to read and provide accurate actuation. Now we're getting somewhere. Still not really sure where, but we're getting somewhere. Sorry, moment of clarity on why we couldn't get this back PCB out. Just realised the CF card port, the pins are actually going to be fixed to this. Ooh. Dangers of buying off eBay, people. This man telling me it was a firmware issue, and actually all it needed was an update and it'd start reading the flash card again. I can now see, and I promise I haven't done this, buried right down on the inside here, 2 pins of the CF card are bent out of place. Somebody has tried to put a CF card with blocked ports in here, inside, and damaged it. That makes me feel slightly vindicated. At least it was well and truly damaged before I got my hands on it. Not that it's better now, of course. Right, you can see on the back, now we've finally got, oh no, it's really bad. So we've got a bent pin over here at the top and 2 in the middle. So the male pins in this port penetrate into the CF card, the female holes, and there'll be some sort of gripping pin. But if you contaminate those with dirt and try and push that in, of course it results in, as you can see, some mangled pins. So glad to have that out. Now this board, I think I would go out and call the motherboard. This has got all of the compute on it. Still can't bring myself just to break that ribbon if it doesn't need to. There you go. Battery box out. So this is the business end. This is the fun bit. This is what I really, really wanted to see. Oh! So this is actually the prism that you look through. And it is full of rubbish. This is I would go as far as to say this has been water damaged. That is disgusting. So the image comes up through here, and then listening to that, weirdly, listening to it, listening to something. If you listen, that textured surface makes me already think that's a Fresnel lens. And it comes up here to this apexed set of mirrors, which is clever because it means you get a sort of 2D retroreflector. So a retroreflector, if you imagine you took a cube and cut the corner off, so you ended up with a triangular based pyramid. And if you made the inside surface of all those triangles mirrored, you'd get the basis for a retroreflector. And it doesn't matter what angle you shine light into it, you always get light out at the same angle. And that can also have the properties in 2 dimensions. If you've got mirrors that are in a corner like this, when you look into one mirror, you're looking at the reflection back out of another. So you don't get a mirror image, you get a straight image. So if I was looking in a mirror and I moved that way, my reflection would move that way. It's weird, but it's what happens. And that's what they've got at the top here. Presumably that's so you don't get a mirror image when you're looking through the viewfinder, which I'd never thought of being an issue, but clearly it is. Then you've got another mirror at the bottom here, which brings it straight back to the eye. So at the moment, with this mirror arrangement, I'm looking straight down here. Okay, I hadn't expected that. I'm assuming this is the sensor, the actual bit that senses light and turns into electrical signals, which is all of this. It moves. And I hadn't expected it to be able to move. The only possible thing I can think of that is my DSLR has got a sensor cleaning mode, and I've never really worked out how you would clean a sensor inside a device. I can only assume that's what that little movement does. It's part of the cleaning routine. I can't see any other reason why you wouldn't want that absolutely fixed in position. And this must be the sensor. Oh yeah, look at the state of that. Even that's covered in rubbish. Okay, right, something else I had to learn about cameras when this all started. You'll see a lot of cameras described as full frame, 3/4 frame, half frame, or even 4/3 frame. Now, that is the physical size of the sensor. So the bigger the sensor, the more light can fall on it, and the more light is generally considered a good thing. It basically means you can take prettier photos without having to open the aperture and sacrifice depth of field, or gain depth of field, depending on what you're going for. But it also means you don't have to up your ISO, which in digital photography is no longer the sensitivity of your film to light, it's how much gain you're putting through the sensor. And if you up the ISO really high, it will get quite grainy and look enhanced. And you've probably taken a photo with your phone at night and it's looked a bit grainy. If you took the sensor in a phone, which is probably about this big, 1/4 of an inch, maybe less, versus this, which is probably getting on for an inch in diagonal measurement, that size means it's getting so much more light on it every second, and that means you get better quality photos. That size is related to a 35mm film, so a full frame camera will have the sensor the same size as a 35mm film. I think if I've just said that wrong, please correct me. And the next thing we're going to get to is the shutter. Now I hope I'm going to be able to get to this without it all falling apart and properly demonstrate what a rolling shutter looks like. Although the way this is going, I'm not feeling all that confident. So behind this module, which has got the mirror which protects the sensor, as you're taking a shot, that will lift out the way and expose the shutters. Now this shutter, you can see, is made up of 2 halves. You've got the half which comes up from the bottom, and you've got the half which comes down from the top. Now, depending on the shutter speed and the length of time that you want the sensor exposed, it won't show all of the sensor at the same time necessarily. It's entirely possible that the 2 movements would only expose a small amount like this at any given time. And as this moves down, the top one chases, just providing that same little slit of exposure at any given time. And that's called a rolling shutter. Now, you've probably seen certain photos or videos that are shot using a rolling shutter, and it looks like something's become diagonal as it's moved. Now that's because physically, between the shutter being exposed at the top and the bottom, whatever you're filming or photographing has moved, and that's the shutter mechanism. And you see it's actuated by these two tiny little solenoids. Oh, there you go. So this looks like it will be the illumination for the heads-up display, these sensors. When you're looking through the viewfinder, this gives the illumination for the segments to let you know what focus it's in. Well, there it is. Everything, and wow, there is a lot to it, in a DSLR camera. We've seen focus control, which I'd expected to be motor actuated on here. Actually, it's not. It's just digital feedback based on an actuating pin that sits on the front of the camera over there. That surprised me quite a bit. There's an awful lot of processing and onboard compute on here. I'm kind of surprised these haven't fallen victim to hackers a little bit more, who fancied some sort of high-powered compute to try and run Doom. Let's face it, that's what people try and do more often than not. Got a nice screen, a couple of very intricate motor and control mechanisms. I'm still a little bit confused by this XY positioning alteration. That must be some inherent part of the camera which I just wasn't aware of, that it can adjust the position of the sensor and calibrate itself, I guess. Please let me know if you've got more of an idea than I have in the comments. Look, just look at the number of parts, screws and components that went into making this camera. No wonder they cost so much, and that's not to mention the raw cost of the high precision, high quality sensors, optics and mirrors. No wonder a DSLR camera costs so much. That's about all we've got time for today. I hope you've enjoyed watching this one. If you have an idea for a teardown yourself, or you'd like to join in with the conversation, join us over at the Element 14 community at element14.com/the electronics inside. Thank you for watching. I'll see you next time.